Hello, thank you for joining us. Today's presentation is called Maximizing Run AI Gains, an intro for data scientists. So who is this for? As stated before, it's for data scientists and researchers who are now using Run AI. And why are we giving this presentation? It's just to inform on some of the best practices with Run AI. So before we move on, I just want to go over a common workflow that we see with a lot of data scientists. And so, assuming this is your data scientist and we've got time here on the x-axis, the first thing that the data scientists will do is provision a GPU resource. Then they might start up a notebook and then start exploratory analysis where they will create their code, modify blocks of code, and then test blocks of code. Basically, they just want to get their scripts up and running. And then they'll go ahead and do their training and maybe hyperparameter tuning. And what we see is often they'll run their entire notebook. They'll go back, modify a few things, rerun the notebook, modify a few things after it's done, and they'll just continue this until they're happy. So this is actually not the best way to do things, specifically with Run AI. And so why not? First, we have to understand the goal of Run AI. It is software that seeks to maximize GPU utilization. Please note that that is different than allocation. What we mean by utilization is actually having your GPU perform computations, not just be allocated to a specific person or task, to actually have it be doing things. And so this is a common GPU utilization chart. It would look something like this. The top one, we see sporadic use. And then here we've got consistent use, but it does not fully saturate the GPU. And then we have some that are high use, but we have long periods of inactivity. Ideally, this is how we want our utilization chart to look over time. We want to fully saturate our GPUs all the time in a perfect world. And so that's what Run AI does. And it does this by using two things, the dynamic scheduler and the fractional GPUs capabilities. And just very quickly, I want to review some Run AI specific terminology just to sort of inform what it means. So basically, there's two types of jobs. And for both of these jobs, resources are allocated as long as the job exists. Now, we've got interactive jobs and we have training jobs. So what interactive means is that the job runs indefinitely, and the only way to stop it is if the user deletes it. That is what is meant by interactive. For a training job, it is a job that runs until the script finishes, and it'll automatically stop once it's done. That's what is meant by training. Now, the key thing to note here is that for interactive jobs, resources can be tied up forever, potentially, in theory, right? Whereas in training jobs, resources are only tied up while the job is running, and once it's done running, then the resources are released. So if we have our workflow that looks like this from earlier, it can lead to a utilization that looks something like this. And this is a very real utilization chart. And so the first thing we notice, we've got this sporadic and infrequent usage of our GPU, which makes sense because we are during the analysis portion, we're trying to build our code, so we're not actually running things constantly. And then, of course, there are times where we are using the GPU in a steady way, but we don't fully saturate it. We don't fully use it. And then, of course, worst of all, are these long periods of idle usage. And so how do we do things correctly with Run AI? So the first thing is to use the scheduler for training and tuning and any ETL jobs that you might have for large sets of data. So if this is how you would normally do things, you just want to go ahead and send that job to the scheduler and let the scheduler take care of the GPU allocation. And if this is your utilization over time, what the scheduler will do is minimally, it'll remove those gaps of idleness, and it'll keep everything sort of running without you having to interact with it. And of course, the best case scenario, if all GPUs are used, it'll actually go ahead and use all of the GPUs available. And it can do something in between. If 2 GPUs are available, then it'll use 2. If 3 are available, then it'll use 3. And you want to use fractional GPUs for the analysis portion. And so if you were to normally allocate yourself a full GPU, rather than doing that for your analysis when you're building your code out and doing exploratory analysis, you can just allocate a fraction like 0.1 of a GPU with RunAI. And that means other data scientists can also do the same thing. So you can have 10 data scientists, all with 0.1 of a GPU sharing one GPU. And what that will mean for that one GPU is that utilization will go from this to something like this, which is much better. But really the important thing here is the fact that it makes all of these other resources available and free for those high compute tasks. And so to put it all together, let's say our utilization charts look like this top, or what's shown on the top without RunAI. So the first thing we can do is for these tasks here, which represent analysis, we can all just run these concurrently on one GPU with the fractional GPU's capability. Here we've got consistent usage, and we have, but it's not fully utilized. We can combine the two. We can use fractions and the dynamic scheduler. And then, of course, for those heavy jobs, the dynamic scheduler will make sure that all GPUs are being used whenever there's jobs to be done. And so we can see how our average utilization over time would decrease drastically by using RunAI properly. And the net effect is that resources become free much sooner and more work gets done in less time. And so to summarize, whenever you're doing interactive jobs, you want to be using fractional GPUs. And so basically, whenever your GPU usage is sporadic or intermittent, when you're writing code, debugging code, things of that nature. You want to use the dynamic scheduler when you've got consistent GPU usage, like running an entire script, performing ETL or a training job. And you want to use both the fractional capabilities and the scheduler when you've got consistent usage, but it is low. Now, there is one particular use case where you would use a full GPU for an interactive job. It should be done rarely. But for example, if you're trying to figure out the max batch size to fully saturated GPU, you'd go ahead and start an interactive job with a full GPU and figure out that batch size. But once you do that, you want to go ahead and send that job to this scheduler and then delete that particular interactive job. And then just some quick tips that some data scientists have found useful. It's really easy actually to convert a Jupyter Notebook into a Python script. You just use the nbconvert command, and then you can just go ahead and run the script as a Python script. It is important to note that you have to comment out any cell magic because it won't convert properly. So just be sure before you convert in your Jupyter Notebook to comment out those cell magic lines. And then if your workflow looks something like this, where you're running a notebook and then modifying it and then running it again, modifying it. So instead of doing that, just create multiple copies of the notebook and then modify each one as needed, convert them to Python scripts, and then just submit it to the scheduler. Let the scheduler handle, the completion of those tasks. So you don't have to worry about it and you can move on with your day. And if you use configuration files, for example, YAML files, which I do a lot, with your Python scripts, you can create multiple configuration files, and then you can just submit each configuration to the job scheduler. And that's it. Thank you for joining us.